Our goal in this section is to solve quadratic equations, which of course look like ax squared plus bx plus c equals 0, by three methods. By factoring, which we've already done before in chapter 5, by the square root property, which is new, and also by completing the square. So a quick review of solving by factoring. If I'm solving by factoring, I'm going to get it in standard form with a 0 on one side. That's important. Then I factor x minus 3, x plus 1 equals the 0 I need. And then either the first piece has to be equal to 0, or the second piece has to be equal to 0 to give me a product of 0. So x is equal to 3, or x is equal to negative 1. Part B, same idea. Get a 0 on one side, and then it looks like this is factorable, x plus 2, x minus 2. So it pops out two solutions, x is negative 2, and x is equal to positive 2. So this we've already done by factoring in chapter 5. The second method is solving by the square root property, which says if k is positive and I have x squared equal to some constant, I can square root both sides, and then x would be positive or negative the square root of whatever that number is. So our goal for this method is to basically have something squared equals a number. If it's only x, it's even easier. For example, if we solve these, we are ready to square root both sides, so x is equal to positive or negative 2. 2 squared is 4, and also negative 2 is 4. Same thing here, the x squared is alone, so x is plus or minus 5. Not much work to be done. Same thing here, z is equal to plus or minus square root of 18, but this we can simplify further. So we'll break it up as a 9 times 2, and the 9 will pop out a 3. So I have 3 square root of 2, but I have to account for both answers. So z is equal to a positive 3 root 2 and a negative 3 root 2. There's basically, again, two answers. We'll solve a couple more. So my goal is, remember, to get the squared quantity alone. Before I do anything, I got to move the 2. So p squared is equal to 7. Now I'm ready to square root both sides. So p is equal to plus or minus square root of 7. And since I cannot simplify, I am done. Same thing here, my goal is to get the squared quantity alone, so I'm going to subtract the 1 first. And I have z minus 1 squared equals 9. Now, since I have the squared quantity alone, I'm ready to do what I did here. Square root both sides, and I have z minus 1. Remember, for every two items identical, 1 pops out, plus or minus 3. So I really have two equations to solve, z minus 1 equal to 3, or z minus 1 equal to negative 3. And I can get my two solutions, 4 and negative 2, or my two solutions. Okay, solve this one by the square root property. Again, my eye is on the squared piece because I want to have this. So I'm going to divide by 7 because it's multiplied. That's going to give me 3x plus 1 squared equals 2. Now I'm ready to square root both sides. So I get 3x plus 1 equals plus or minus square root of 2. So I'm going to subtract 1 from both sides. I have 3x equals negative 1 plus or minus square root of 2. And then last step, divide everybody by 3, so x is equal to negative 1 plus or minus square root of 2 over 3. So my two answers, or two solutions, are basically irrational answers. Negative 1 plus root 2 over 3, and negative 1 minus root 2 over 3. I can leave both of them stuck together like this, or separate. Last type is solving by completing the square, and this involves more work. Nevertheless, our goal really is to have something squared equals a number, so we could use this idea that we used upstairs, square rooting both sides. So completing the square takes a little bit. So our steps are to get it in standard form, ax squared plus bx plus c equals 0. Then move the constant c to the other side. Then make sure the leading coefficient a is 1. If not, divide all by it. Then you do the half business. This is the key step. Once you do that, you have this, which is what you wanted, so you can use square root property. So we're going to solve this by completing the square, though factoring it would be easier. Directions say by completing the square. So we're going to make sure it's in standard form. It is. We want to move the constant c to the other side. So I'm going to add 3 to both sides. And when I do that, I'm going to leave some empty space. Then make sure the leading coefficient is 1. A is 1, so I don't have to worry about that. Then do the half business. Remember, this is the key step. So here's what I mean by the half business. Take this coefficient of x and half it. That's going to give you -1. Save this because it'll pop up later. Now take it and square it, which is going to be a +1. It's always going to be a positive number, and use it. How do you use it? You add the 1 on the left, and whatever you do to the left, you must do to the right. So you add the 1 to the right as well. Now once you do that, you're going to factor the left side. And you're going to add the stuff on the right side. So you're going to get x, and then -1, -1 to get the -2x in the middle. So you made a trinomial that's definitely factorable, equals 4. Now that's a binomial squared, so I'm going to rewrite it as a binomial squared, and notice now I have what I was looking for. I have something squared equals a number. Completing the square always gets you to this place. Now I can square root both sides, and I have x minus 1 equals ±2. I can add 1 to both sides, so x is equal to 1 ±2, which can be simplified to a 3 as one of my solutions, and -1 as my other solution. Let's solve this by completing the square. So I have it in standard form. I move the constant. I leave some space here. The leading coefficient is 1, so I am ready to do the half business. Half of 6 is 3. Save it. Take it and square it, and that's going to be 9. You're going to now use it. So add 9 to the left, add 9 to the right. Now the left side is going to be factorable, x plus 3, x plus 3, and the right side is going to be 11. So this guy that you're saving is always going to appear in your binomials. Just like up here, when you save the -3, or the -1, I'm sorry, it appeared in your binomials when you factored it. So that's why I put the word save next to it, because it's going to pop up later. So now I have x plus 3 squared equals 11. I can square root both sides. X plus 3 is equal to plus or minus square root of 11. Subtract 3 from both sides, and we got x equals -3 plus or minus square root of 11. So I have two answers. -3 plus root 11, -3 minus root 11. Again, let's solve by completing the square. So I got to get it in standard form first. That's going to be 2x squared minus 14x plus 2 equals 0. They are all divisible by 2. I'll take care of that in a second. Actually, I need to move the constant first. So let me move the constant to the other side. You don't have to move it first, but you'll probably make less mistakes if you do that. I've seen less mistakes that way. So these are gone. Now the leading coefficient is not 1, so I have to divide everybody by a 2. That's going to give me x squared minus 7x equals -1. So now I'm ready to do the half business. Take half of the coefficient of x, which is -7. That's just going to be multiplying across -7 halves. You're going to save this guy. Then you're going to take -7 halves and square it. And when you squared, you get a 49 on top and a 4 in the bottom, and you're going to use this. So add 49 over 4 to both sides. Now factoring the left side may seem scary, but remember what we had noticed. The number you save is always going to be the second item in your binomials. So these two identical binomials multiplied out will give you this trinomial. And on the right side, I'm going to need a common denominator of 4, so I'm going to multiply by 4 over 4, negative 4 fourths plus 49 fourths, common denominator 4, and it looks like I get a 45 up on top. So I have x minus 7 halves squared equals 45 over 4, and I'm finally ready to square root both sides. So x minus 7 halves equals square root of 45. Remember, I can think of this, split them as two separate ones, and the bottom is going to pop out a 2. And square root of 45, I can simplify further because that's a 9 times 5, and that's going to pop out a 3. So I really have x minus 7 halves equals 3 root 5 over 2. Now I'm going to add 7 halves to both sides, and I have x equals 7 halves plus or minus 3 root 5 over 2. And since they have the common denominator of 2, we might as well put them all together over the same denominator. So I have two answers, 7 plus 3 root 5 over 2, and 7 minus 3 root 5 over 2. And I can't combine the 7 and the 3 because they're not like terms. This one is attached to the radical 5, and the 7 does not have a radical 5. So notice all the work we went through. Put it in standard form, move the constant. Make sure the leading coefficient is 1. Do the half business. Now you're ready to square root both sides and simplify to get your final answers. Let's solve this graphically because it says use the graph to solve it. So we don't know A, B, and C. We can't really solve it using completing the square, but we do know that usually we have a parabola graphed out of some equation quadratic like this, and in this case notice the y is being replaced by 0. So it basically says y is 0, find x's from the graph. And if I go to the graph, here is where the y value is 0, and here's where the y value is 0. What are those ordered pairs? So those x's with y value 0 are 1, and the other one is 4. So all we really did was find x-intercepts. So keep in mind, if your quadratic equation is set to 0, you're basically looking at the x-intercepts of your graph. Okay, it says a table for this parabola is given to the right. Use it to solve this equation. Again, we don't know what A, B, and C are, but we do know that the y value has become 0. So we go to our y value and we see when that y value is 0. 30, 18, 8, 0. That works. All negative numbers, I don't need those, and that works. So those are the two places where the y values are 0. Which means what are the corresponding x values? My solutions are negative 2 and x equals 5. All I did was pull it out of the table just like I pulled it out of the graph here. So a quick summary of what we just did. Solving quadratic equations that have this form, of course, with a of not equal to 0 can be solved by symbolically showing all the algebra, either factoring, square rooting both sides, or completing the square. Or you can do it graphically by just pulling info out of the graph like we did. Or you can do it numerically. If a table is given, you just pull info out from the table. So the main three we focused on was algebraically or symbolically, where you show all the work. These two can be done rather quickly from the graph or the table.